Hi. Thank you for being on my talk, Elevating Experiences with Service and Events. Let me start by saying it's really an honor to talk, because over the years I've been watching a lot of DjangoCon videos and PyCon videos, and it has been a big part of my learning experience. So who am I? I'm Melhin. I have been a software engineer for a while now, predominantly fumbling at building software. I work at Chemondis, which is a marketplace for chemicals. I'm a software engineer over there, and I lead one of the Scrum teams. I'm always tinkering with some kind of technologies and also frameworks, and the talk over here is part of one of the explorations that I've done. So I've not run it on production, so with codes. And I also have a lot of incomplete projects in GitHub. This is my GitHub handle, so you can see it there. Before I start, how many of you have attended my talk in PyCon Italy? Yeah, okay. So there's going to be some repetition, but the examples are going to change a little bit. So let's start, right? So I want to set the base first, so I'm going to go with some mandatory definitions. Some of them are very common known, but just to set the base. So polling, predominantly very simple. Client at every interval just asks the server whether there's an update or not. There are two kinds, they're short and long. Yeah, the short ones are, it's just instant, and the long ones hold the connection, wait for an update or release it. How many of you still use polling? Me too, yeah. All right. Then WebSockets. Now WebSockets are bidirectional in nature, right? So the messages flow from both sides, from both the client and the server. It's done over TCP protocol, and it's not part of the normal HTTP flow. Then we come to service end events. Now service end events are unidirectional over a single HTTP connection. So the client connects to the server, and then the server holds the connection and keeps sending the data back. This is what we're going to talk about. So I'm going to look at how is this done, right? So there's actually an event stream format, and the event stream format is pretty basic. It's just like a stream of text data, which is UTF-8 encoded, and the messages are separated by a pair of new lines. So it's basically /n/n, server sends a message to the client. So this is an example. There you could also see that this colon, and the colon is a place to have a section known as comments. So you could see that data over here is like a comment saying that this is the data. Event stream format also has another form. It's known as named events, and this is particularly useful because now you can also express what kind of event it is. Just not, you don't have to kind of fit it in the data. It's just there. So for instance, this is an example. I hope you can see. Yeah. Yeah? Okay. So there's like a user connection and a user disconnection event, and then the client can actually react differently. So I'm going to explain stuff using code. I hope I'm not covering the screen. Do not use this code in production. It is not. It doesn't work. It's just easy for me to explain it like that. All right, so let's look at a simple streaming view. And the simple streaming view doesn't do much. What it does is it basically sleeps for some time and then sends a count. So let's take it apart. So the first part is the async generator, and this forms the main component of the streaming HTTP of the server sent event. And the async generator is very simple. Over here, what it does is it just sleeps for a second, increments the increments the count, and then yields the count. Yeah, so the server just sends the count back. And this is what I explained earlier with the named event. So you can actually have, this is how the event is formed, right? So event is new, and the event has a data, which is the count. And how is this done? So streaming HTTP response is how this is done. And streaming HTTP response has been there in Django for a while. right? So it's basically a mechanism where Django uses, where it holds the connection and sends data. In the sync world, in the risky applications, usually what we do is you use it for like sending over huge CSVs or Excel sheets and stuff like that, where you don't want to store it in memory. But what happens there is the worker connection is actually held, right? So your worker is occupied at disk. Now in the async side of things, when we use ASCII, it's part of the event loop. So the worker is kind of not held, and then you can actually have multiple of these, right, using one worker. Another part that I want to show, and this is, if I'm not mistaken, kind of introduced in 5.0, where you actually get to catch the cancellation error. Now, this is important because what it happens is, your view now gets to know that there is actually a disconnection happened, like if someone closes a tab or a browser or something like that, without explicitly sending a disconnect event, right? And the browsers, it's always a bit tricky. It's also a place to have cleanup, right? You opened a Redis connection or, connection to a different database or something like that, then you can just release that. How do you develop this on local? So I was using UVCon mostly, and there are two things that I want to point out specifically. Is the reload, so that it behaves like run server, and the timeout graceful shutdown. And if it's not there, then when you reload, so when you code and you save, it doesn't reload because the connection is still held. So this improves the experience. I'm bad at doing demos, so I have bought off screenshots. Is it okay? So I'll try to explain. So on the left side, you see the server logs. That's predominantly what it is. And on the right side, you have the curl. So you can actually test this using a simple curl command. You don't need any other tools. Now, why are we doing this, right? So our primary focus, right, always revolves around providing user value. And over the years, the synchronous Django has been around for 20 years or something like that, and it has like a stable upgrade history, has a lot of good third-party ecosystems and things like that. So you have your Django synchronous app because it's solid, right? But you could always do with some kind of real-time interactivity. And there are certain set of applications that have real-time interactivity as their core principles, right? So like messaging apps or collaborative tools or live streaming platforms and online games and real-time dashboards, right? This is just some examples. But most of your applications might not need it. But there is still something that you can use to kind of improve the overall user experience. And that's notifications. Notifications is a place where you can actually, just add it in any app that you have. And it also allows us to offload heavy processes. So you can just offload it to a salary worker, and then as and when things happen, you can actually send the response back. Now, let's imagine how do we do this synchronously, right? Using polling. So the normal pattern is just, so this is the notification system. So any interaction creates a record on your notification system. Like in your model, you just have user A send a message to user B, right? And then, since we are polling, we're just asking repeatedly, is there a new update, is there a new update? And when there is one, you send it back to the client reacts. Now let's make this real time. Now this is a suggestion, and also an exploration. So you keep the asynchronous app running as it is. So you have all the endpoints that create messages, and the polling endpoints are all there. You then just add listeners towards the end of the notification. So if a record is getting created, then you basically add a listener over there, publish it to a common channel, And then you have your asynchronous app running separately. So your synchronous world is as it is, nothing changes. You're just adding another asynchronous app, and then the asynchronous app listens on the common channel. So if there is any kind of messages that are coming in, the asynchronous app picks it up and sends it back to the client. There is actually a very good talk about running sync and async app separately. I'm going to point to a link towards the end of my talk. So just representing what I just said in pictures. So you see the synchronous app, there's an async app. Now it also uses the same ecosystem, right? So it uses Redis and DB, whatever you're using. And then this is like the connection. So the moment there's a connection from the client, the async app then starts listening on a stream. I'll come to the stream. And whenever a sync app has an interaction, it publishes this to a Redis channel, and then the async app just sends it back. Now, Redis is a common channel. So Redis predominantly is deployed along with most of our applications, so it's always readily available. You don't have to change or add a new infrastructure as it is. It also might be available on your local machines. And one important thing, and thing that Django channels uses this a lot, is the Redis data structures. There are a lot of Redis data structures that you can actually use. And one interesting data structure is Redis streams. It was introduced in 5.0, I guess, and it has a lot of use cases like event sourcing and logs and also notifications. So how do we, let's conceptually look at how do we use Redis streams here, right? So you have your listener, right? And then you listen on multiple streams. So this is a feature of the Redis stream, right? So you can have multiple of these streams. You can have, let's say, post stream, and then you have a user stream, and something comes in a post, like a new mention, and let's say something comes in the user stream where someone says, hey, this user is offline. Now with one listener, you can actually have you can actually listen to multiple of these streams. So the listener can be configured however you want. It's a very interesting concept. Also, you can use it for multi-device. So let's say you have, I don't know, phones, tablets, or laptops. So you see your tablet is now listening. There's a message coming in. The tablet gets it. Then the phone comes in. Now the phone also doesn't get the old message because it's just linked there. Then the new message goes both to the tablet and the phone. So on and so forth. So now let's look at an example. So usually you show the code first, or you do the code and then show the demo. I'm doing it a little differently. Hopefully it works. Okay, all right. So what do we have here? So we're going to mimic a real world application. And how are we going to mimic it? We have 3 streams. So you have 3 users, and all of them have their own feeds, right? And so this is now they're listening on their feeds, right? They're just staying there. And you can see that they have their, whenever someone mentions their, let's say, email address, then it comes to a feed. Now, immediately you can see something over here. So we are not just listening on messages, but we are also listening on events of a different type. And that's basically an online event, right? So this is how you do the Redis stream thing. This is, so someone posts, yeah, you get it on the feed, and without doing anything else. And how is it related to your real world? So let's say the sync app has all this capability, right? And whenever there's a notification that says, hey, there is a new message, you call your endpoint. So you can see, yeah, Oracle Neo and Trinity are talking to each other in the feed. There's also one more thing that, I explained before about the whole cancel thingy. So here, let's say we go ahead and close the feed. Yeah, now we're going to close the feed. The moment we close the feed, you can immediately see that there are like an offline message coming in both of them. Yeah? So that's what I'm going to show up front. That's what I'm going to show now. How do we do it in code, right? So before we move into the details of it, it's very important that we select a common data pattern. Okay, so you have to have an agreed data pattern between server and the client. And it's basically just to standardize the stream response and also add more visibility to the fields that are present. And you could also do something about the API spec over here. So in our example, I'm using the same code, right? So I've showed you the demo. The example, you're using an event type, an event at, and a text. Okay? So event type could be user being online, user disconnecting, or there's a new message. The sync part of the application looks something like this. So this is the interaction that I was mentioning before. So on the notification side, towards the end, you're actually just doing this, just this part. All the other sync part just remains as it is, right? You're not touching any of the sync applications. You're just adding this. And what happens here is you're taking a user ID, putting it as the stream name so that it belongs to a particular user. You're adding the message to the top of the Redis stream, and then you're adding an expiry. Now, expiry is an interesting concept over here. Why? Because sometimes the clients are disconnected and then they don't need to be notified. And in that case, it's always better to just put an expiry and it just expires. Redis takes care of it itself. And on the async side, you have an SView. Just don't look at the authentication code, but I'm just saying you can use the same authentication that you're using in your sync apps, yeah? The cookie authentication also. And here what you do is, whenever you're connected, and that's what you saw over there, when someone is connected, it shows online. And that's how you send it is, you send a status when you connect, and then you listen on the streams. So you can listen to multiple streams. It's just a method. We'll go in detail over there. Another stuff is actually reacting to events, right? So if you have multiple streams that have multiple categories, one is a connection stream and another one is like a new notification, you can react differently. But you should follow the same data pattern. Don't do what I did over here. I just put HTML there. But you should follow a pattern over there. And the next one is basically a heartbeat. Now, this is also an interesting concept. So when you're listening on streams, you're also giving timeouts. And this is important because the moment someone, it's important to send a heartbeat for load balancers, because some of the load balancers that are configured, some of them, not all, disconnect the connection at idle time, and you might have to tweak your infrastructure. So what we are doing is maximum not touching the existing system, but just adding the functionality, right? And heartbeat could also be used for multiple things. You can actually use it like a user counter, saying that how many users are online, and there are multiple things that you can do with that. And finally, you send the offline event, right? So whenever someone cancels, you say they're offline. Now this is the listener, and the listener is very straightforward. What it does is it listens to multiple streams. You can see towards the bottom, there's a user key and a connection stream. And there's also something known as a last ID return. So that's what is used to pick the reference in the Redis streams. So there's a special thing in Redis streams where you can actually do $, and then it always places on the top of the stream. So you can just ignore all the other messages. Now we're going to look at some front end. The demo that I showed you was done mostly using HCMX, but I'm not good at HCMX. But just for representational purposes, so this is how it looks like. Of course, there's CSS and small body HTML, but this is predominantly how the connection looks like. So this is the connection block. So you see the connection block, and within that, there are two things. So there is one where you're actually listening to a post, And the moment there is something that comes up, like an update, you're triggering another URL from there. And then you also have the status. In this case, I'm just injecting whatever comes in into the HTML. You could do different things with that. A very simple thing. So this is just like a developer tool view of how things are. So you can you can't exactly see, but the last one was the stream connection. And whenever a new notification comes in, you just call your sync app to get the content out of it. Now, why not just use WebSockets, right? So again, WebSockets has its use, but not a lot of our use cases have bidirectional communication, real-time communication. You don't need to change anything in your infra. Again, we are just trying to keep things as it is by adding more functionality to it. Compressions are also not supported out of the box. There's a good talk about SSE, WebSockets, and long polling. I'll post the link again just towards the end of my talk. So, does everything work? Yeah. So, in my experiments, there are things that you'll have to be aware of. And one of them is settings. And since you're running both the sync and the async app together, you have to always be aware that there is some things in the settings that you have put like 5 years ago and forgotten about it, which is not async compatible. Middlewares, again, same problem. Install apps, that's something that you have on you, like each of your applications would have a lot of install apps that might behave differently. But the main limitation is connection. So browsers generally have a connection limit of 6 SSE connections. And you will have to get over that. And to do that, you might have to use some of the JavaScript functionalities, like having like one place to call the SSE connection and then use broadcast and things like that. So this is something that you'll have to be careful before you do the SSE. And to look at middlewares, it's always good to look at how Django does, because Django has a lot of middlewares which it has made both sync and async compliant, and it uses an interesting technique to do that. Predominantly, this is something of a detail, but it's also good to look at Django. How does it use the thread pool executor, especially in the ASCII ref library, which is also well documented. That's it.